Good day everyone. In today's video, we'll be talking about how to apply our first order differential equation, particularly on electrical systems. So in today's particular video, we are going to be focusing more on RC circuit, that is resistance capacitance circuit. Now, have you ever wondered why immediately you plug in your charger, your phone don't get instantly full? Rather, it takes time, and this time is determined by the time, the time constant. RC circuit and RL circuit have time constant, which both have different, they have different equations, which we are going to be determining in this video, particularly on the RC circuit. Alright, so the equation you want to know using Kirchhoff voltage law is that V of T is equal to IR plus Q over C. This is the equation you want to know. So, and you have to know that current I is change in charge, the time rate of change of charge. So it means we can replace this with this one in this equation. So the equation now becomes V of T is equal to dq dt r plus Q over C. So this is the equation you want to know. Now another equation you have to put in your mind is this: the time constant T tau is equal to R C. For an RC circuit, if you want to determine the time constant determines how fast a capacitor charges. Alright, capacitor stores charges, but how fast does a capacitor store this charge is determined by the time constant T is equal to RC. So you want to keep these two equations somewhere. Alright, so quickly we're going to be solving some of the examples, and we'll make sure that we're on the same track. Alright guys, so consider this question shown in your screen right now. An electrical circuit has a resistance R 2 ohms and a capacitance 1 farad. So let's write out our given data. R is equal to 2 ohms and capacitance C is equal to 1 farad. It is connected to a constant voltage source of E is equal to 6 volts. So this is the battery. And the capacitance is 1 farad. Now we have two questions given here. One of the questions is that formulate the differential equation governing the charge Q of T on the capacitor. Now it is vitally important that you memorize the equation. I said you should memorize, or if you can't memorize it, write it somewhere and make sure you are always reviewing it so that it can stick in your head. So when they say formulate the differential equation here, what they meant is from your Ohm's law, V of T is equal to what? IR, right? Then plus, because it's an RC circuit, you are going to include your Q over C. So we already know that. Alright, we already know that V of T is equal to dq dtr plus Q over C. Alright, our resistance is given, our capacitance is given, and our E is given. So what we are looking for is Q, for the charge Q. We know our battery, which is given as 6 volts. So if we substitute 6 in place of V of T here, and 2 in place of R, and 1 in place of C, we can get our Q. So here we have 6 is equal to R is what? 2 dq dt plus Q is what? Q is what we're about to look for. All over C. C is 1. Anything divided by 1 will remain like that. So you will now see that this equation looks just like a first order differential equation, right? So this equation looks like a first order differential equation. So what do? The first thing we do is to look for our integration factor if, right? From our previous video, we said our integrated factor is exponential integral of p of t ds. If we said any equation that look like dy dx plus p of xy is equal to q of x. Alright, this look like it after we divide both sides with 2. So we have dq dt, right, plus is equal to, if you divide your 6 by 2, you're going to get 3. So now can we now get our integrated factor I of f? So I f now is equal to exponential integral of our p of t in this case. So our integrated factor here is p of t dt, because we're integrating with respect to time. So our integrated factor is equal to e integral of p of t here, right? Yes, so it's 1 over 2 dt, and integrated factor is now equal to exponential integral is 1 over 2t. So I've gotten our integration factor. So what do we do next? We're just going to apply that formula. Instead of multiplying each term of the equation by a of t and we're elongating everything, so I'm just going to memorize 1 over the integrated factor multiplied by integral of our integrated factor dot q of t, right, dt plus c. And when we do that, we will know that our q now is equal to, our integrated factor is exponential half t, right, multiplied by exponential 1 over 2t. Our q of t is 3, then plus our c. So we have to integrate this, because there will be an integral symbol here. So integrating that, we're going to get 1 all over alright guys, so this is what we now have applying the formula. If you don't understand the formula, watch the previous video, introduction to first order differential equation. Yeah, just watch that video, you're going to understand how we got this formula. So our q now is 1 all over exponential 1 over 2t. If we want to integrate exponential function, let's take our 3 out. We want to integrate our exponential 1 over 2t dt. Our u substitution will work here. This is just like exponential 1 over 2x ds. You can say exponential instead of 1 over 2x, we're just going to say u dx, where our u is 1 over 2x, right? If everything is e to the exponential 1 over 2x and we said e is equal to u, it means our u is just 1 over 2x. So our du now is just going to be 1 all over 2 dx. So it means that our ds is equal to 2 du, right? So if we replace our 2 du here, we're going to get exponential e to the power of u dot. Instead of ds, we're going to put 2 du. So we have 2 integral of exponential u du. And if we want to integrate exponential function, it still remains that function. So the final answer now becomes 2 exponential u. What is u? Our u is 1 all over 2x. So by the same token, we are going to see that our integral of exponential 1 over 2t is just that q is equal to 1 over exponential 1 over 2t 3 integral of what's instead of integral now, our integral becomes multiplied by 2 exponential 1 all over 2t plus our c, right? So what is our u? Q now is now equal to, let's multiply both sides with 1 all over this. So this becomes 3 times 2 here is 6, so we have 6 e to the power of 1 all over 2t all over exponential 1 all over 2t plus c all over exponential 1 all over 2t. So here we go with this. We now know that our q is equal to 6 plus c exponential negative 1 all over 2t. Now, if you look at the condition again, in your screen right now, you will notice that, however, from the question, we can see that they say find charge q of t at any time t, given that q of 0 is 0, right? We already know that q, I'm going to be using blue pen now, is equal to 6 plus c exponential negative half t. Now the question says find q of t when t is 0. Q was 0. So when this was 0, t was 0. So we're going to look for c now. So 0 is equal to 6 plus c exponential negative half times 0. This becomes 1. So I have a 0 is equal to 6 plus c. So that my c is equal to what? Minus 6, right? So my c is equal to minus 6. Now, to do is to, replace minus 6 here. So we're going to have that q is equal to 6 plus, instead of c, I'll put minus 6 exponential negative 1 over 2t. So I have q is equal to 6 minus 6 exponential 1 over 2t. So this will be the final answer for this problem. Alright, so go ahead and try this one on your screen right now and submit your answers in the comment section. I'm going to be going through them and making rectifications if there is mistake. Alright, subscribe to the channel and see you in the next.